Before replacing a fuel pressure sensor, accurate testing is crucial to avoid unnecessary costs. The fuel pressure sensor measures pressure in the fuel rail or injector system, typically 30-80 psi in gasoline engines, and converts it into an electrical signal sent to the engine control module. Begin with a visual inspection for any physical damage, corrosion, or loose connections. This basic check can reveal obvious issues before more advanced testing. Next, perform electrical testing using a digital multimeter to measure resistance, aiming for 2 to 10 ohms for a functional sensor and voltage output at the sensor's pins while the engine is running. Simulate pressure using a fuel pressure gauge connected to the fuel rail's Schrader valve to verify actual PSI against ECM readings. This confirms if the pressure matches expected values. For advanced diagnostics, an oscilloscope can capture waveform patterns to identify intermittent faults that other tests might miss. In some cases, bench testing, where the sensor is removed and tested with a pressure calibrator, can simulate conditions more accurately. Always remember to relieve fuel system pressure and wear protective gear for safety. Accurate fuel pressure sensor testing is crucial for correct diagnosis and cost savings. Studies show that as many as 40% of suspected FPS failures are actually wiring or ECM problems. According to ASE certified mechanics, proper testing with gauges and multimeters can catch around 60% of false positives, saving both time and resources for technicians. Future fuel pressure sensors will increasingly incorporate self-diagnostic capabilities through secure data transmission, which will reduce the need for manual testing. Until then, technicians must use digital testing tools over analog methods. Widespread adoption of Bluetooth-enabled multimeters and diagnostic scanners that connect to OBD2 ports allows for non-invasive testing. Proper testing practices are essential for accurate diagnoses and efficient repairs in automotive maintenance.